everybody, Alicia Panzarella here, taking a look at our Module 2 Engineering Design Challenge, which looked at tackling the problem of runoff. So I decided to connect our activity with a framework for K-12 science education and more specific to Dimension 1 and Practice 3. Because Dimension 1 looks at that scientific and engineering aspect, which really is what this activity did. It married together that science aspect of looking at how does our world work and then how can we apply that to the design process. And in doing so, Practice 3 really comes out because we planned and carried out an investigation based off of our technology resource, and then we investigated with our erosion bottles. So starting off, step 1 and 2 of the process was defining the problem of what is the best land cover for a healthy watershed. That brought about some subsequent questions that really revolved around soil composition, and then that soil composition was really my identifying constraints. So knowing that these were some of my constraints, I also said, hey, I'm not quite remembering enough from my Envirothon days to really start this problem, start investigating this problem. So my brainstorming started with research, which looked at infiltration and runoff and how can we really define those. And that's really just a matter of, how much rainwater can our soil hold? And once it exceeds that capability, that's when we have the runoff. So I did have a misconception about that coming into this. I thought runoff was always man-made, and it's not. It could just be that you have really clay-like soil. And that's where the different filtration levels come. So a high filtration has a lot of sand, it's gravelly, the pores are big, giving it that type of soil composition, whereas moderate is a fine texture, so it's moderately deep pores, and that's more silty, whereas your low filtration is very clay-like, so very compact. So knowing that we have these 3 different types, that's where my research and the technology aspect started with the simulation. So I ran all 3 different filtrations. I gave one of my constant variables was that the amount of rainwater coming in was going to be 8 centimeters, which was pretty high for the simulation. And then I looked at the different types and then how much infiltration versus runoff it produced when looking at those different types. And we can see kind of where a tipping point was from, hey, infiltration and runoff is pretty even right here, but then after that, runoff really exceeds the infiltration. So my setup, since I couldn't really get different soil, not compositions, but different soils. I didn't have access to clay, and I also wasn't able to plant any seeds with this. I decided to change my composition by adding in sand, because that's what we saw really kind of makes the distinction between the different infiltrations. So my high level has 1 cup of sand, my medium level has a half a cup of sand, and then my low level has no sand, and I packed it together to try to give it more of a clay-like composition. So then what I did is I brought each one of the different filtrations over to my kitchen sink. I had the sprinkler on for 1 whole minute, just spraying on it as if it was raining. And then this is the amount of runoff we got. So we can see the high, small amount of runoff. It also had a small amount of sediment. Medium, we see that it's growing, more sediment came through, and then the low actually started to overflow by 50 seconds. So we're seeing, even just with the addition of sand, how that changes the runoff. So pretty cool. So as far as the engineering design process, I would have liked to improve this by prototyping more, prototyping with the grass, having more iterations by having more soil types, or even just changing the sand amount. And then ultimately analyzing the activity, I really went back and forth between the science and the engineering side. But I had said, I think this involves a little bit more of the science aspect, because we're really looking at how the world works. But, we're carrying out the investigation for that, but we are going to then, design solutions based off of our findings. And then we have that technology piece with it. All right, thanks for watching.